Hey folks, Doug Blake with Body Design University. In this video, I want to talk to you about inertia and exercise performance. Now, the concept of inertia is pretty straightforward, especially when we're talking about it within the context of exercise and training and resistance training and the type of weights, barbells, dumbbells, anything. By the way, it doesn't necessarily have to include resistance training. It just becomes more problematic when done incorrectly, exercise performance wise, and using this concept of inertia. So inertia itself is, to put it very simply, is the tendency for objects, for things to maintain consistent motion or to remain at rest and then be affected by some force or something that pushes it or moves it in some way, shape, or form. So we understand inertia in everyday life. So really simple example of this is you're driving your car, right? And let's just say you put it into drive and you start moving forward, you put the gas on. And let's say you're going 20 miles an hour, right? Now your vehicle weighs a couple of thousand pounds, right? So even at 15 to 20 miles per hour, if you take it out of drive, put it in neutral, take your foot off the brake and just let the car move, this is called inertia. In other words, the vehicle will continue to move until some force or something stops it or slows it down. In the case of a vehicle like a car, as long as you don't hit anybody or hit anything, what is actually going to slow it down? Well, it's going to be the road, right? The surface of the road against the tires of the vehicle. It's going to be the mechanical issues related to the turning, right, of your wheels and tires and all those things. So that's going to create friction. Friction becomes the stopping force, so to speak. At higher speeds, of course, it's going to be related to the internal mechanics of the turning of the vehicle and the mechanics of the engine. That's going to slow it down. Really simple. But from the outside, looking at that vehicle as it continues to roll forward, it doesn't want to stop. Not necessarily. And like I say, you have everything, even air resistance to a certain extent, but not at the slow speeds, is going to slow the vehicle down. So any force, anything that is going to change the tendency of an object to continue to move forward or stop it or start it is generally what we term inertia. If you want, you can Google inertia and get the full explanation in physics because that's where you learn it. In biomechanics, we're looking basically at the how the body moves. So the body is the object, like a car or vehicle, and it's going to move, right? Because you're doing an exercise. And I'll give you a great example of this is squats. If you go down on a squat, your torso or your upper body is like that vehicle in the car. It's going to move, and gravity is what's generally pulling it down. Put resistance on, and you're going to have an increased potential speed to move down. But what do we do? What is exercise all about? Well, it's using muscles to change the direction, to slow down the movement that you're going through. So this concept of inertia relates to how you're actually performing the exercise. I'm sure most people would not, if they're doing a squat and you have 100 pounds on your back, just going to drop down as fast as you can, right? Inertia is basically going to be the explanation for why your body with 100 pounds on it, without anything stopping it, will simply go boop and crash down to the ground. But what do we use, right, in exercise? Because we're exercising, what are we using to change the motion or the speed of that particular object, which in the case of a squat is going to be your torso or upper body? Well, we use muscular power, muscular strength. So when you're performing exercises like squats, bench presses, dumbbells, anything that involves basically resistance, even push-ups, because your torso acts as the resistance while you're doing the exercise. Inertia basically is saying that your body, the part that's moving, doesn't want to stop moving. It wants to keep going in the steady direction it's going down on a squat, wants to keep going down, right? But we use a force to stop that movement. And so the force obviously is going to be muscular contraction. Now, inertia and exercise performance, therefore, is related and connected by how we perform, right? How fast we go, on a particular exercise, both through the eccentric or the negative, and in the case of a squat, going back up on the positive. Generally, the issue when it comes to inertia and exercise performance is generally, not all the time, but generally going to be related to that portion of the exercise known as, like I just said, the eccentric or quote, the negative portion of the exercise, because the eccentric portion of any exercise forces the muscle to act as a force to slow down the movement of the limb. Pick any exercise you want. Again, I'll choose the squat in this case. So we generally start the exercise in a standing position, then we bend or flex the knee, flex the hips, and go through dorsiflexion at the ankle. And as we go down, as the hips come down, we are using muscular power through the eccentric contractions of those particular muscles that we're working, the quads and the glutes, for instance. Those muscles are acting as slowing mechanisms for the torso that, due to inertia, just wants to drop down. Well, we use the muscles to contract and slow the movement down. And that's what the eccentric portion of any contraction is really doing when you do a squat or a bench press. So as I go down on a squat, you generally will tell your clients, and I hope you do it too, you'll generally say slow on the way down. Why do we tell individuals to do their negatives or their eccentrics slowly? Inertia, to overcome inertia. Remember, inertia wants you to just whoop, keep going at the same speed. You do that in a squat, even without any weight, you're going to bust up your knee. More than likely, you're going to cause some damage, whether it's acute or chronic over time. This is why we don't bounce at the bottom of a squat. I know you can lift heavier weight, but that's not the point, or I hope you realize that's not the point. So inertia needs to be controlled, right? Um, we need to use muscular contraction through the eccentric portion into that stretch position to slow down the pace or the movement speed of a particular limb or body segment. And that's where inertia, remember, inertia is the tendency for objects, things, your torso, a part of a body, to continue moving at whatever speed it's moving at, without being impeded by a force. Okay. So if the force you're going to use is muscular contraction, it's therefore related directly to the performance of the exercise. So, what is the takeaway from understanding inertia and exercise performance? Always keep in mind when you are doing basic standard exercises, and we're talking about average everyday clients. Of course, this works with athletes as well, but the idea is that with average clients, okay, those individuals that are somewhat fit, relatively fit, not fit at all, we need to be exceedingly careful on those different portions of the exercise, right? That could potentially cause injuries to the joints. And the most important part of the exercise, okay, I'm not talking, forget muscular hypertrophy, forget all this. But the most important part of the exercise to ensure that you overcome inertia is generally going to be the eccentric, or what we call the negative. Think of every exercise you do, and you should be doing this as a trainer anyway. You should know what the concentric, or when the muscle shortens under tension, and the eccentric portions of each of these exercises are. Generally, remember I've used the word generally, the single most important part of the exercise with respect to overcoming inertia is generally going to be the eccentric or the negative. Going down on a squat. We can go down at a fairly quick pace if you want, but you must slow it down, right? You're overcoming inertia, the tendency for the torso to just go straight down at that consistent speed. On a bench press, we generally start with the elbows locked at the top position, right? You're on your back or incline, whatever. And what do? You let it down through the eccentric, because we're generally discussing the pectoralis major as the primary agonist. So we must go through the eccentric and do what? At the bottom. If you allow inertia to take over, then the bar goes straight down and crashes onto your chest, which is a no-go. We don't want to be doing that. And so what do? We overcome the inertia of the bar and the weight, wanting to maintain that consistent speed, and we use muscular force through the eccentric or negative, the lengthening of the muscle under tension to slow it down. And as we slow it down, we're able to essentially protect the joint, right? And even the muscle itself from injury. Dumbbell curls. Think about when you're doing a dumbbell curl. We normally start the dumbbell curls with the dumbbells at the bottom position, or a barbell, doesn't matter. And we then generally, at least I do, and with clients, I always do this. I start off with the concentric contraction, meaning I shorten the muscle shortens to move the bar up to the top position. But then, and there's not really an issue there, folks, when it comes to inertia, so to speak. I mean, you can speed it up at the top position. But again, we're talking about protecting the joint in this case in the proper performance of the exercise. So, what now do we do on a dumbbell curl or a barbell curl? We don't just let the bar drop down. In other words, we don't allow inertia to take over and just keep the movement going at the same speed. What do? We overcome the inertia by doing what? By tensing and slowing the muscle down as it moves into that bottom elongated, stretched position. And that's kind of the idea. So think of any exercise you do. You must understand that where the concentric and the eccentric contractions occur. And then always, from a safety perspective, on the joints in particular, is focus on the eccentric, particularly as you get closer and closer to the changeover point, right? To where the muscle stops moving, or the limb stops moving, and you then transfer back over to the concentric. Now, generally, I call that the stretch component of the exercise. Remember, there's four components to every exercise, right? The positive, the negative. This is what we're talking about. The peak contraction, which occurs at the top when the muscle itself, in this case, when the muscle itself is shortened, maximally under tension. But the way more important part of the exercise that we understand just through basic research and just doing it yourself is that as you go through the eccentric, as you get to the bottom portion of this particular exercise, as the muscle lengthens under tension, we're going to get to a point where you hit that isometric contraction, where essentially the limb stops moving and you change direction. It's that point right there that you have to have overcome inertia, because if done too quickly, you know what can happen. You can not only injure the joint, you can rupture, or at least partially rupture, the tendons and cause soft tissue damage that makes no sense. So, what's the takeaway again? Slow. All of this to help you to understand. This is why we always say slow on the negative. In fact, as you come down through the negative, you actually slow it down further and further until it essentially stops. That is your stretch isometric. That's what we call it. Stretch isometric. And that ensures that you don't damage, injure the joint necessarily through this ballistic type of movement. So inertia needs to be overcome through the negative component of the exercise, generally, right? The majority of the time. And in doing so, you are now performing the exercise correctly by keeping tension on the muscle, right, through the negative. Not bad idea to pause it as well. And you are ensuring that you are minimizing, if not eliminating, the risk of injury. You can't eliminate it completely, but you really minimize it to the point where it's not a essential component or issue when you're training somebody. So slow on the negative, slow it down to the point where it stops into that stretch isometric. You have overcome inertia at that point, and now you can proceed with the concentric or the positive part of the movement. I am hoping that this was helpful in understanding this basic concept. Let us know how we can be of assistance. If you want me to go a little bit deeper into this concept or some other concept related to this, please let us know in the comment box below. As always, if you haven't done so, subscribe to our channel. Give us a thumbs up. Leave a message. Let us know how helpful it is. And we'll see you next week. Take care.